We're reading 7th grade math lesson 5. The first question says there are 120 students in 7th grade and 40% of them are boys. So we can convert 40% to a decimal straight off the bat. So that would be 0.40. We would multiply 120 students times 0.40. That would give us 48. So we know there are 48 boys in the 7th grade. And number 2 says calculate 25% of 72. So we can convert 25% to 0.25. Then we would multiply the 72 times 0.25, and that will give us 18. So A is our correct answer. Number 3 says 8 kilograms of apples cost $20. So 8 kilograms of apples over $20. How much do 6 kilograms of apples cost? So 6 kilograms, and we don't know the price, so our denominator would be x. We would cross multiply, so 8x is equal to 120. We'll divide by 8 on both sides, and that will give us an answer of $15 for 6 kilograms of apples, which is C. Number 4 says 6 workers finish a project in 16 days. So 6 times 16, that would be 96. So that means one worker takes 96 days to complete the project. So we do the same thing. 4 times x, because we don't know the number of days, would be 96. 4 times x is 4x, equal to 96. Divide by 4 on both sides. So x is 24. So our answer is D. We'll move on to the next section, and this question is unsolvable, by the way, because there's no problem. Number 7, it says a set of dishes is marked down 30% off the original price, and the sale price, so the 30% off price, is $19.60. What was the original price? So we can classify an original price as 100% of something. So 100. So the price over 100%. 30% off is 70%. So we would do 1960, because that's 70%. So we would cross multiply here. So once we do that, we would get an answer of x is equal to 28, which means the original price, like not sale price, was $28. So our answer is C. Tell me which number is greater, and it just lists numbers. So general rule is that when we use a number line, the number on the right is always greater. So for example here, we start at 0, 1, so forth, so on, and 7. So 7 is on the right side, so it will be greater than 0. So 7 is the greater number. We would apply this for like most of the numbers. So -2 and -3. -2 is further right than -3, so -2 would be greater. For negative numbers, the smaller or the larger negative number is always the one that is closer to 0. So -1 is right next to 0, so it will be greater than -5. 0 is always greater than a negative number, but it is smaller than a positive number, so that's like a rule. So 0 is greater than negative, but positive is greater. So we know we know 0 is greater than -4. For 5 and -2, positive numbers are greater than negative numbers, so 5 would be greater. We can use the same rule for 3 and -13. Positive numbers always greater, so it will be 3. For this section, it says, for the given value of A, find the value of -A and absolute value of A. So absolute value is just how far a number is from 0. For example, on the number line, if this is 0, we have 6 and negative 6. They are both 6 units away from 6, so the absolute value is 6. And then we can find the value of negative a by just making a negative out of the absolute value. So we would add a negative to 6. So these would be our two values for negative a and absolute value of a. One is 6. So you can do the same thing. 13.6. It's 13.6 away from 0. So it will be 13.6 for the absolute value. And then we add a negative to find the negative a. So these terms. And then we'll do the same for negative 1 and 1/9. So that means it is 1 and 1/9 away from 0. So that will be our absolute value. And we can just add a negative to the negative 1 and 1/9. So negative is always positive. So it would actually be 1 and 1/9 and 1 and 1/9 again for our answer on number 3. For a is equal to negative 3, we know it's 3 units away from 0. And we would negative times negative is always positive. So that would be plus 3. So it would be 3 and 3. So we can get 2 of the same answer. So for 2.7, we know it's 2.7 units away. And then we would add a negative right here. So our answer would be negative 2.7 for the negative. So these are the values of negative a and absolute value of a.